Great, thanks, Greg. Uh, okay, so I'm first, and then Greg will speak. My aim is for about 7 minutes here in our short presentation, but we'll have some talk later. A framework for Big History 2.0. So this is a joint talk. Greg and I have this as a paper going into the periodization issue of the Big History Journal that David LePoire is editing, and our papers in the Big History Journal were a matter of discussion. This is a little bit of background. We're a matter of discussion for a couple research meetings of the Big History Research Group. Greg and I met through the Big History publication. He did not know my work when he published in the journal, and I did know his work from the journal, but I had already published my Quarks to Culture book, so I wove Greg's journal work into my journal paper in 2020. But I give you this background because we shared some similar visions. It was sort of a convergence. And we call this Big History 2.0 because we think that there are ways of being very explicit about the major periods of big history that are different from the thresholds, classic thresholds, which David Christian has said was a more of a pedagogical structure. And it's also, we would put in energy considerations into a Big History 1.0. Not that energy is not important. I've done a lot of work in energy myself, about with the biosphere and wind energy, but really the energy by itself does not tell you a lot directly about the creation of new forms and the dynamics that are creating patterns in big history. So the proposal here is going to be using evolutionary dynamics as the marker for a fundamentally new initiation of new periods. So Greg, if you could put the next slide on, please. So this is PVSR, propagation, variation, and selective retention, or as I originally was just using PVS. And this has to do with factors that are propagating patterns, factors that are varying patterns, and factors that are selecting patterns in a somewhat of a you might say competitive, but they can be cooperative as well in a competitive way. The famous example of this is of course Darwin using this, and Wallace using these factors, these sub-processes, to unfold the dynamics of evolution. And we in this paper are taking these as taking the appearance of new PVSR dynamics as excellent markers for new eras or epochs or dimensions in the big history story. Now, there's two main reasons for this. One is that the appearance of such dynamics opens up new possibility spaces to bring in from the possible into the real in fundamentally new ways. This, of course, was Darwin's great insight. We heard yesterday about cultural evolution. We've been also hearing today about collective learning as an evolutionary advance, and we're going to hear more in this talk, especially from Gregg, about animal learning, animal cognition as a PVSR metric. So that's the first one, is that the appearance of evolutionary dynamics clearly opens up new spaces for fundamentally different productions of forms. The second reason that we propose this as an important marker is that these can be this can be debated. It's not just a personal opinion that this seems fundamental to me, or I drew upon an expert. The big history people could actually go into and ask, okay, what is the propagation, what is the variation, and what is the selective retention in multiple ways that are happening? And it can be studied, therefore, in big history as a comparative a chunking, the way Gustavo Lau talked about chunking we can chunk these PVSR emergences and do comparison and contrast among them. Next slide, Greg, please. This is going to be very quick. Many of you know this. This is the combogenesis scheme, and that things on relations at a prior level combine into a new thing that give new relations and at a new level. Next slide, Greg, please. I propose that this cycles up, and it's a way to start from the small things in the universe and build up to the big things that contain the smaller things of previous steps. So it's not that stars are not important, but we do not contain stars themselves in us. But one can follow this logic and get a series of levels, which is shown in the next slide. Greg, please. Going from the fundamental quanta up to the geopolitical states. Now, so in my book, I have chapter length analyses of why we can say that combogenesis happened at each of these, and I'm not going to go through this at all now. Instead, I'm going to show you the final slide and spend a little bit of time on it on my section. Thank you, Greg. This was in my 2020 Big History paper, but I've circled in red and put a slight coloration in the appearance of the evolutionary dynamics in 3 cases. And also I've put on the left-hand side, not the appearance of evolutionary dynamics, but that's the start of the universe, start of our universe that we know. And the way I see it is that the physical chemical progresses from the basic quanta up to molecules. We heard a lot from the Grinnin talk yesterday, really interesting on chemical evolution. But I'm not marking that as a separate epoch because, as Grinnin said, this had to exist in some way, but he was right. There's been a lot of work on it, but it's not well understood. But if we go to the next one, biological evolution, very important, one of the traditional thresholds, and then cognitive PVS of animals. This is animals learning, so they can do trial and error. There's actually an advance within the animal evolution of the kinds of learning that animals have, but it has been noted that it is an evolution type process in a more general sense. Gregg will say a few more words about that. And then the third or the fourth circle I have there is cultural evolution, which we've been hearing about in several of the talks. And this involves both an enhanced personal cognitive PVS in one's mind, the way we sort through ideas and make decisions about what we're going to do, and collective decision making, collective PVS. So I'm going to end in a second. I just want to lead into Gregg's in saying the 4 circles correspond to what Gregg independently marked as his joint points of major transitions in dimensions. And Gregg, I turn it over to you at this point.
Great. Thank you so much, Tyler. Yeah, so what's really exciting is Tyler and I were mapping what I call the evolution of complexification, and then Tyler was able to really give a good specifying word about that, combogenesis. And so we have a combogenesis of a bringing together of things that also include big jumps that give rise to what Tyler called different realms. I called them different planes of existence, but they were clearly the same way. Now I represent it slightly differently, and I developed this diagram called the tree of knowledge. And so here's the tree of knowledge diagram. And what it depicts is the sort of the hot evolutionary inflation at Big Bang at 3.8, by 3.7 billion years ago, it's underway. And we see the evolution of complexification in the material realm, which is essentially going from energy into the structure of matter, from particles to atoms into molecules. And what this graph is tracking is complexification, or the combogenesis complexification. It is not tracking aggregates, and I'll make a point about that in a little bit. But if we align what Tyler was saying with the basic structure you see here. Tyler's 4 circles correspond to the emergence of the material dimension. Then the green would correspond to the emergence of the biological dimension. And then, yes, there is a break and an emergence of what I call minded animals, cognitive animal dimension. That's the evolution of animals with sensory motor nervous systems and complex active bodies. Go down about 500 million years ago, we got the Cambrian explosion, whereby prior to that, you get sort of jellyfish and worms. And then all of a sudden, you get a lot of complex active bodies, sensory motor systems, things like crabs. And then between, say, 500,000 years ago and 50,000 years ago, we get another dimension, the dimension of culture here in relationship to the evolution of hominids into persons. One thing to very much note about this, and Tyler alluded to it, he specified it very clearly that we have, especially at the level of life, mind, and culture, what you have are the PVSR or the PVS dynamics of propagation, variation, selection, retention. And what I like to highlight, kind of going along maybe with some of Ken Solis's work or others, is that what's emerging here are complex adaptive planes of existence that are mediated through novel forms of information processing. So we can think here about genes and cells and communication networks between entities. So cell-cell communication. So the communication between and information processing within. The same is going on with animals. So you get a neuro information processing to create a hierarchical control system within an animal. And then you get animal to animal communication to build animal networks. And then, of course, we have a linguistic, symbolic, syntactical information processing communication network, which we're dialoguing about right here. So the realms and the idea, especially at the level of life, mind, and culture, we can talk about both chemical evolution. There's some models of sort of actually Stephen Hawking's latest articulation of the universe is sort of a Darwinian physical cosmic evolution. So people have speculations about that. That's much more tentative. But at the level of life, mind, and culture, I think we have lots of evidence to believe that there are these PVSR dynamics. And if we add the idea that what they're operating on is a complexity building feedback loop that gives rise to information processing communication networks that give rise to new adjacent spaces in a generative way. And that's what we mean by life. I'm introducing the term minded animals here, which is necessary for our grammar to talk about the concept of mind, and then ultimately cultured persons. Now, what's really cool about this is if we combine, especially when we look at me and Tyler coming independently, if we combine these realms and these PVSR dynamics, what we agree with, which is implicit in the diagram, is the model of combogenesis. Well, this I actually arrived at. I noted something pretty later after I built the tree of knowledge that actually each one of these has sort of a stable primary whole entity that's associated with them. And then we apply the lens of combogenesis to that. When we do that, we get what's called the periodic table of natural behavior that's mapped by science. And that's what you see here. What the periodic table of behavior highlights, just like with the tree of knowledge, that there are these dimensions of behavioral complexity. And you can see why I've aligned the diagram this way, so that the gray is matter, the green is life, the red is mind, and the blue is culture. And there are general object field relations, like you could say, oh, there's a rock or there's a planet, but there are actually primary levels of analysis that actually align directly or very closely with what Tyler was saying. So we have out of sort of the Big Bang, we get the emergence of particles like an electron. They then coalesce into the stable whole, the primary whole, which is an atom that would be mapped by the periodic table of the elements. And then we see the evolution of chemistry, in particular organic chemistry. And that organic chemistry may have given rise to that chemical evolution, whatever, but we didn't see the parts, biological parts. I'm highlighting the gene here because the emphasis here is on information processing. There could be organelles and other kinds of elements, but the gene then represents a particular primary part at an information unit. And the primary whole at the level of life is the cell. And then, of course, cells will grow into various kinds of ecological organizations. You can have groups and colonies of cells, of algae. And then, of course, they're going to coalesce in different kinds of organizations, especially once we get the shift into eukaryotic cells, which then are themselves complex cells. And then they make complex multicellular things like plants and fungi. And the argument is that one of those complex multicellular systems developed another information processing within it based on PVSR dynamics, and that's animal mindedness. They're then networked together by neural networks, which then are then modeling the organism-environment relation. Mind one here is just a term inside basically a minded animal. That's a complex active body behaving as a whole through a sensory motor loop. And of course, we can get animals that are engaged in group dynamics, family dynamics. And then finally, the system that I built basically says, hey, propositional language or symbolic justification was a really key sort of unit of information. It gave rise to question-answer dynamics and the building of systems of justification. That's what I argue, actually. Mind 3 is kind of maybe more what was meant by mind earlier on, sort of thinking, but it's actually talking, justifying, propositioning. And then we get these networks of proposition that organize in relationship to families and communities. The long story of this is that or the short summary story, I should say, of this big presentation is that Tyler and I are looking at the landscape of big history, and we're noting that, hey, virtually all big history models have a time by complexity frame on it. But what we have is a general, not really well specified pedagogical model that shows thresholds, but I don't think the thresholds actually give us the necessary vocabulary to talk about the evolution of complexity from quarks to culture. I think we need to shift from a general model of emergence of complexity to differentiating the layering process of combogenesis from general processes that give rise to aggregate forms. So like a solar system or a galaxy. This gives rise to point 2, which is that we want to explicitly note the difference between emergence that's characterized by these combogenic leveling and other emergences. In fact, I intuited this with the tree of knowledge. It became very explicit with the periodic table of behavior. And then I realized Tyler had done excellent work really articulating the logic of it and giving a language in a very synergistic way. We're also arguing that we should recognize the difference between emergence that characterizes these combogenic levels from aggregates into the jumps that may give rise to the big realms as a function of PVSR-dynamics. So that's propagation, variation, selection, which opens up this new design space. I would argue for life, mind, and culture, we can specify those PVSR-dynamics really as catching generative potential because they're actually giving rise to new information processing communication networks that we can characterize as complex adaptive planes of existence. My whole work is on kind of connected to the first, what is mind? What is psychology? What is the field of psychology? Been doing my whole life work is devoted to that question and placing psychology in the pantheon of both the natural sciences that bridge into the social sciences. One of the things that becomes clear on this is you have to really think about minded animals in the world. We got blinded to this because we gave rise to I think a misguided notion that there's a physical world and a mental world, and those are two different kinds of worlds. That's not an adequate grammar to make sense out of the world from my vantage point. There's actually, we need to think about energy, matter, life, mind, culture, and the tree of knowledge shows us why, and it highlights as a whole realm of existence called the domain of minded animals, mediated by neuroinformation processing and animal-animal communication. And ultimately, then that gives rise to an argument for a new vision of big history, shifting from the thresholds that are pedagogical to a differentiation of complexity that emerges through aggregates, and then complexity that emerges through a layering combogenesis process that then takes place in 4 great domains of matter object coming off Big Bang, and then matter object into living organisms, into minded animals, into culture persons. And we think that this gives rise to a big history 2.0 that maps the time by complexification process with more nuance, more clarity, and more consistency between various scientific enterprises, so we can network our systems together in a way that is both more coherent and meaningful, and hopefully, speaking to the threshold 9, really organize our grammar of understanding as we shift into this new phase of our evolution.